right, y'all, let's go over this real quick. So this is just not really, what we're doing on the warm-up doesn't really have anything to do with what we're going to be learning today. This was just, hey, these are some concepts that we did a lot last semester that we just wanted to review. And so I just want to point out there's two questions on here. The first question says to solve, and the second question says to simplify. And so this semester, we're going to continue talking about the difference and what that means. When you solve equations. What does an equation have to have? Equal sign. And then simplify, there's no equal signs here. These are just expressions. So we're actually going to get an answer in this equation versus these are just going to be shrinked down expressions. Okay, so that's kind of important to know the difference between. Most of you guys were rocking and rolling on number 1. What did y'all do? I'm going to write it down, but y'all kind of coach me through it because I saw a lot of y'all do it right. First thing, what'd you do? Distribute. And so we had negative 10x. A negative times a negative is a? Do I distribute to the 1? No. Nope, because it wasn't in the parentheses. And then I had negative 3x plus 51? Yeah. Yes. What'd you do right here? Those two. Combine those, okay? Added them together. And that's essentially all you really have to do on these last two problems. You simplify that down. So then we would have negative 10x plus 16 equals negative 3x plus 51. Okay? So get it to where you've simplified the left side and the right side. I'm going to continue with my line. And then basically, that's supposed to say 51, not a 5x. Basically, now what we want to do is we want to get it to where we have the numbers on one side and then the variables on one side. So I'm going to move this 3x over by adding. I'm going to move this 16 over here by subtracting. I'm doing two things in one step. That's okay. And those will go away. And I get negative 7x equals, what is that, 51 minus 16? 35, thank you. And then I divide. And so what do we get for x? X equals negative 5. I saw a lot more people put that on their paper than just Anya. So x equals negative 5. So we get an answer. We solved. We got a solution. Now, simplify. We're not solving here. I'm actually going to do the third question instead of the second one. So I'm not going to get x equals. I'm going to get an expression. But it's going to be a simpler expression. But what am I first set to do? What do we know we do whenever we see a number in front of parentheses? Distributing. So I'm going to do that. Negative 2 times 3x is negative 6x. Negative 2 times negative 4 is positive 8. Watch those signs. And then at this point, do I have anything else that has an x with it? Anything in my list of terms? No. So I'm just going to leave that negative 6x there. But what about these two guys? The 8 and the negative 12. What are they?
Same.
They're just the same. They're like terms. So we just put them together. What's 8 minus 12?
4.
What kind of 4?
Negative.
So I would have minus 4. Negative 6x minus 4. Is there anything else I can do to clean that up?
No.
So then this is my answer. This is my simplified answer. So I would just stop there. This problem, we're really going to get to this in a couple not this week, but in a couple weeks, we're going to have a lesson about this. It was on the warm-up. I don't know that it really meant to be. But technically, if anyone did figure it out, I want to get the answer on there. But if you're still a little bit confused, just hang tight because we will go over it. It's still combining like terms. But we did put an exponent on there. And we're going to talk a lot about exponents this week, okay? So I have a 3x squared. So some of you guys were saying like that you needed to square the 3, and you don't because the squared is only on the x. But do you see how I underlined the 3x squared and then the negative x squared? Why do you think I underlined those two? What do they both have? X what? Squared. Okay, so like just how we said, these are just two plain numbers. Those are like terms. These guys are like terms. And then I have a 5x. What's another like term to a x? Just a plain x. And a 2x. Those are like terms. And then I have a number right there that doesn't have any term to combine with. So that's basically how you look at it. And then we just end up putting the coefficients together. But that's another lesson. So here's the answer in case you did get it. It's 2x squared plus 7x minus 7. And if you didn't, then we will fix it in a couple days. Okay? So, like I said, today's warm-up didn't really have too much to do with what we're going to get into today. I believe Canvas should have some stuff on here. We're going to be talking about this week and next about exponent rules. It's going to seem like quite a bit today because we're going to go over a lot of rules. The problems look kind of scary sometimes, but the math behind it, really all we're going to do today, you guys, is add, subtract, and multiply. That's really all we're doing, okay? So bear with me. We're going to do some practice. I've got just a few practice problems for you to get to at the end on a little homework thing. It's a little coloring thing, color by number once you get your answers. So hopefully it'll be kind of fun. But it's going to be a little bit today and next class. So look here on the page before the warm-up, page 2. Oh, there is a page number there. We put this on there. If you grabbed a star chart, that's fine. You don't have to put it back, but I do want you to look at this page real quick. Flip back over. Need you to wake up. Gotta be with me. Flip back over. We screenshotted on the star chart where your exponent properties are. Okay? And we also just want to make sure we know some vocab because I don't want to be saying words and you're like, what is she talking about? What does that mean? So we have a little diagram for you, okay? So the exponent, who's heard the word exponent before? Raise your hand if you heard that. Okay, are those big numbers or tiny numbers? Those are tiny numbers. So exponent is a word that I'm going to talk about a lot. It's a tiny number right there. It's kind of like floating up. It tells you how many times your base is multiplied. Okay, then you have your base, which your base can be a number like it is here. Here my base is 6. But your base can also be a letter. It can be any letter, a variable, okay? And so when we talk about what that means is exponents are a shorthand. Instead of writing 6 times 6 times 6 however many times, we can just write it one way, 6 to the third power. So it's kind of like a shortcut. But there's some rules that are involved with these that we'll be talking about what happens when you multiply with exponents, when you divide, when you power to a power. So we're going to kind of focus on these 3 rules today. Again, more vocab here. Here's a little bit different term for you. Again, your exponent is still the tiny number kind of floating at the top. This time, though, our base is a variable. Okay, so our base, what's attached to that exponent, is a letter. And I'm going to write that in. I'm going to write base right here. And then in this case, the 6 is not attached to an exponent, and so the 6 is what we call a coefficient, which I know we've used that word before. So just kind of knowing what I'm talking about is really important vocabulary-wise. But again, we're learning how these exponents work, learning some rules. We'll just add, subtracting, and multiplying. Okay? Are we ready to jump in to fun times? Are you ready? 2024? Here we are, Algebra 1. Yes? We need to take a little stretch break or something, wake you guys up. Yes? No? Maybe so? All right, let's go to this page, 7.1, exponent rules. Okay? We're going to do a little bit of flipping around here because of the way that this is laid out, but I'm going to kind of go over one rule at a time. We'll learn a rule, we'll do a little practice. Learn a rule, do a little practice. Okay? So the first rule is what we call our product rule, okay? What does a product mean? What do you do if you're getting a product? What operation do you do? What? Multiplication. Very, very good, okay? So product of powers, that's what they named this rule on the star chart. So I call it the product rule a lot, but it means that if you are multiplying, so I want you to circle the word multiplying, it's also bolded for you. But when you're multiplying like bases, and that's important, which means you have to make sure that the bases are the same. An X with an X, a Z with a Z, okay? The rule says, and this is the shortcut, that you're going to, here's the fill in the blank, add the exponents to simplify the expression. So remember I said we're doing 3 things. We're adding, we're subtracting, and we're multiplying. The first thing we're going to do is add, okay? You will know that these problems are done and fully simplified when each variable only shows up once, okay? So sometimes people are like, I don't know how to tell that I'm finished with this problem. Well, you can only have one X, you can only have one Y, you can only have one Z. That's kind of what it will look like, okay? So here's what the star chart shows you for the product rule. It says product of powers right here. And remember, you get this. When you take your STAR test, your EOC in April, you will have this. You just have to know how to interpret it. So do you see right here where it says M plus N? Like that. That's telling me there's a plus sign I'm going to add. Okay? So let me show you why it works, and then we'll do some practice with it. So let's look at this right here. It says non-simplified. X to the third times x to the fifth. How did I know that was multiplication? Because there's a dot. What's another way to represent multiplication? Parentheses. You can do parentheses side by side like that. That also can mean multiplication. Okay? So before we jump to how the rule works, I'm actually going to expand this out. So if I look at x to the third power, what's my exponent? What's the tiny number?
3.
Exponent is 3. What's the base, Heidi? X. Thank you, Heidi. Okay, so that means I'm going to multiply my base x how many times? 3. So x times x times x. That's the first thing that we're multiplying. Now, Jahan, the other side says x to the fifth. So how many times am I going to multiply that base x? What does the exponent tell you to do? Right here. Multiply it 5 times. So now I'm going to write in 1, 2, 3, 4, 5 more x's. We're just going to do this a few times because this is really tedious. But if you look, your first guy, you have your 3 x's being multiplied, then your 5 x's being multiplied. How many x's did we just write down? 8. So my simplified answer I can write as my base is x, and I had 8 of them. And that's my final answer. Now, where do you think 8 came from? Well, what is 3 plus 5? 8. That's why this rule works. That's how this is a shortcut to keep you from having to expand everything out. Because what if they gave you a power of like 100? You don't want to write 100 x's. That would be a waste of time. So we have these rules that can help us simplify without having to do this. I want you to try the second one, though, real quick. Just expand it out so you can kind of see it. This is the last time I'm going to make you do that. Expand it out. Y to the 8th. You got a different base here. That's okay. Y to the 8th times y to the 3rd. Sorry. So you're going to be writing quite a bit of y's in the expanded form right here. Right here. And then write what your final simplified answer would be. So here's y to the 8th. Here's y to the 3rd. How many y's did we actually get? 11. So we can write a simplified answer as y to the 11th. So aren't these rules kind of nice? They keep us from having to write all of those out a whole bunch of times. So that's our first rule. Product rule, you add the exponents. Okay? So we're going to flip over to the next page real quick and do a couple of product rule examples. Okay? So when you finish this one, and again, we're going to avoid having to expand all these out. We're going to use our rule now where we're adding, okay? Remember, you have to add with the same base. So we're going to kind of work up in this section right here. On page 5, it looks like.
So flip over.
Flip over. Okay. All right, so it says simplify. Again, that's going to be the instructions on a lot of these. Simplify. We give you something expanded out. We want to shrink it down, simplify it down, okay? So let's start right here. Look at the one I'm looking at. A squared, there's not even a multiplication dot right there, but they're just side by side. Go ahead and add in a multiplication dot right there.
If there's no sign, what does that mean in math? Like there wasn't a sign. It says a squared and a. It means multiply. When you don't see a sign, just know that, hey, this means multiply. Because there's not a plus sign, there's not a minus sign, there's not a division sign. That means it's multiply.
And they're side by side, like that.
Yep.
Okay? All right, so our rule says if we have the same letter, we add up the exponent. So let's just look at the first one. Do we have the same base in this case? What is our base? A. So we're going to go ahead and write down that base. The base is not going to change. Coefficients aren't going to change. We're not doing anything with coefficients today. So just write down that base. Now we're going to look at the exponents, the tiny numbers, and we're going to add those. Now this problem, this first one, I actually think is kind of tricky. What's the exponent of the first A, Braden? What's the exponent on the first A?
2.
2. What's the exponent on the second A, Mohammed? Is there one there? So what is it implied to be if there's not an actual different number floating up there? What do you think? What? 1. So here's what I always say. If they don't have an exponent written in, kind of like a coefficient of 1, you don't have to write it in. But when I work with my exponent rules, I like to. So I always say, give it a friend. Give it a 1 so that way you can really see what's going on here. So the exponent of the first A is 2. The exponent of the second A is 1. And our product rule says we are multiplying these terms. So what are we going to do? What did we just say? When you're multiplying like bases, what do you do to the exponents? What is 2 plus 1? So we would get a 3. That's our answer. A to the third. That's all we're doing. Adding. Okay? X to the third times x to the 8th. Emma, do we have the same base?
Yes.
What is it?
X.
So write it down. This is a multiplication problem, so I'm going to use my product rule. Ethan, product rule says, what do you do with the exponents? Add. What's 3 plus 8?
11.
Done. Okay, so these problems can be really, really quick. What happens if you have multiple bases, like on this third one right here? Okay, you have a y to the third times an x to the third, y to the fourth. What do we do? What do you think?
I think you would have to add the y's together, the y exponent.
Okay, we would. So I'm going to underline those. So what would that give us? Y to the 7th power. Okay, why did you add those together?
Because I figured that because you can't add y and x together because they're different variables. I figured that y and y are the same variables. So
Exactly.
It's logical sense.
Exactly, that's what the rule. When you're multiplying with the same base, that's the key. So y to the 7th. But are we done?
No.
We can't just get rid of x to the third. Is there anything to simplify with x to the third? No, so we just write it down. X to the third like this. Is it okay if you write it like this? X to the third, y to the 7th?
Yeah.
That's okay too. I probably would do x to the third, y to the 7th because,
Probably prefer that a little better.
yeah,
Because it's x, y alphabetically.
we're not looking at that right now. Okay?
So
All right.
Yeah.
And
That's
so-
what I just did.
And we're done.
Yeah, we'll do some of this. We're gonna run out of work on this one. So, yeah.
So we know that we're done because we have one x with an exponent, we have one y with an exponent, so we're finished, okay? So these are all of our answers right here. So go ahead and try this one right here. Let me help you. What's the exponent on this first m? What I say, give it a friend.
1.
M to the 1, n to the 2, times m to the 3, n to the 5. Simplify that. I like to underline. I would underline my m's, underline my n's, so I can get those straight, but this is still a multiplication problem.
So what's the answer on the top?
All right, Cruz, you got an answer to this one?
Yes.
What'd you get?
M to the 4th.
M to the 4th,
N to the 7th.
into the, did you say 7? Thank you. Perfect. Y'all agree? 1 plus 3 is 4. 2 plus 5 is 7. Done. Can't do anything with the m and m because those are separate. Ooh, we threw some fractions on there. Are we scared of fractions? No, because we got a calculator. So let's talk about our base x. I underlined that one time. So base x. What am I going to do with the exponents?
Add them.
Add them. So I'm going to go to my calculator. Y'all remember how to make fraction? We should. We did it a whole lot last semester. So 2 plus alpha, y equals enter, 4 over 5. And that gives me 14 over 5.
Yeah.
It's not very pretty, but it works. So there's my x. My y, I've got 2 fractions to add.
Why can't you just do two? Why can't you just do two?
2 4/5.
Yeah.
I prefer improper fractions when it comes to exponents. I haven't ever seen an exponent be a mixed number. So I would keep it like that. Because there technically is another exponent rule with fractional exponents that we won't really talk about much in Algebra 1, but you would need to be in that improper fraction. Good question. All right, Nick, what's the y exponent? Can you add up those two for me? You probably need to use your calculator because they're 2 fractions.
I don't even know what we did for the x, so I don't know.
We added the exponent 2 and the exponent 4/5 because those are the exponents of x. So I added those here. So what are the exponents of y?
Like the whole fraction?
Yeah. What's the exponent of the first y?
2/3.
2/3. So I'm going to add 2/3 to what's the second exponent?
1/6.
1/6. So I'm just putting those in my calculator, and that's going to tell me I'm going to put y to the 5/6 power there. So we're just adding the tiny numbers is what we're doing. But we have to go base by base. There is a fraction here, but look at the top. What's happening at the top? What are your bases at the top? B. Okay, so when they're side-by-side bases, they're still being multiplied. So what are you going to do with those exponents? What do you do with the exponents in a multiplication? Add. 3 plus 7 is over. On the bottom, you have a different base. It's base D. So we put base D. I have D to the 5th times D to the, what's implied right here? And then what do I do with those? Add. 5 plus 1 is 6. And then we can't do anything there. Okay? So this kind of leads me into my next rule. So that is all our product rules. So anytime we have side by side, multiplying, 2 parentheses, multiplication dot, no multiplication dot, this is what this is talking about. You go letter by letter. That's the thing with these. It's really, I think it's helpful to break it down letter by letter, base by base, one at a time. Because when you try to start putting it all together, you can get really jumbled up and it gets a little bit confusing. Okay? All right, let's talk about our quotient rule, do a few practice problems, and then we'll take a break, okay? So flip back over to the page before, and we're going to talk about the quotient of powers. Quotient of powers. All right, quotient, vocab. What operation do we do when we are finding a quotient, Anya? Divide. Very good. So I want you to circle the word divide right here. When dividing, again, you have to have like bases. So we're still paying attention to the letters. We can only work within the same letters. Now, dividing is the opposite of multiplying, correct? Okay, so your exponent rule when you multiply is to add. So what do you think your exponent rule will be when you're dividing? Subtract. Very good. So you subtract, and you need to make sure that you do the order top minus bottom. Okay, and there's kind of a little shortcut too that we can think about with this. But technically the rule is you are subtracting top minus bottom to simplify the expression. So we put a little note here. It says variable stays on the side of the fraction where the larger exponent is located. I'm going to talk about that in a second. You're fully simplified when each variable or each base only shows up once. We kind of are going to keep emphasizing that because, again, sometimes people are they're not sure when they're done with a problem. And so that's important to know. You get one of each. Okay? So our quotient rule, again, this is on the formula chart. It says quotient of powers. Quotient rule, they're typically going to be set up like a fraction. Okay? It's very rare that they actually use that division sign anymore. I've seen it, but it's usually pretty rare. So you'll know that you're dividing when you have a fraction like this. And then the rule says that you subtract. So you can see right there it says m minus n. So we're going to expand it out for a minute, show you how it works, and then we'll get to the shortcut to where we can do this by using the rule and not having to expand. But I just want you to kind of understand why. So this one says x to the 5th divided by x to the 3rd. So these are the same base, correct? What's the base, Heidi? On this problem, x on the top. And then so the exponent is,
5.
so that means you have how many x's on the top? 5. 1, 2, 3, 4, 5. This is just kind of our proof. We're not going to do this every time because this is going to be redundant. But then we're dividing that by, on the bottom, we still have base x, which is important. It's the same, but how many of them are there, Miles? On the bottom. Thank you, Miles.
I didn't hear you say that.
It's okay.
On the bottom.
3 on the bottom.
3.
X to the 3rd. 3 on the bottom.
Also right at the top. I didn't know the top.
So, what is anything divided by itself? 7 divided by 7. 100 divided by 100. Negative 500 divided by negative 500. X divided by X.
X.
Anything divided by itself
Anything
is
divided by itself is 1. So what I kind of can do here is the way that I've separated this out, I can have these little pairs of x's. I can have one x on the top and one x on the bottom, and those are going to divide to be 1. Okay, a lot of times we say cancel out. Technically, that's what's happening. They are canceling out, but really they are simplifying to be 1, and we don't have to write that 1 anymore. So I can mark out 1 on the top, 1 for the bottom. Can I keep going? I got another pair right there, 1 on the top, 1 on the bottom. I even got one more, 1 on the top, 1 on the bottom. Can I keep going now? No. So what's left over, Zane? 2 x's, and where are they? At the top, okay? So that means I can write that as my simplified answer will be x to the 2nd power. That is in the top. When you don't have to write the over 1, you can really just write x squared, but we'll talk about the 1 in a minute. But there are 2 x's left over, and then there's just a 1 on the bottom, so I can also write this as x squared. Now, think about the rule. Top minus bottom. What's 5 minus 3? 2. So I ended up with a x squared. Okay, so this is just kind of the proof. This will be what you probably get to here. The other way I kind of like to think about it is like a tug of war. Okay, when you're dividing, you're working against something. We've got 5 x's on the top versus 3 x's on the bottom. Who's got more, top or the bottom? The top has more. By how many? How many more do they have? 2. So my answer is x squared on the top. Okay, let's do this expanded form, and then we'll do 3 practice problems, take a break. X over x to the 4th. What's the exponent here? What does it need? It needs a 1. So I only have 1 x on the top. How many x's do I have on the bottom? 2, 3, 4. How many things can I cancel out?
1.
Only 1. Just that 1 pair right there. So how many are left over?
3.
But where are these left over?
Bottom.
They're on the bottom. X to the 3rd. What is left over on the top?
1.
1. Okay? 1s have to be written in the top. They do not have to be written in the bottom, but I would have to write it like this, representing that there was something above that. And it was just that factor of 1, again, because that's simplification. So if you think about tug of war here, x to the 1 versus x to the 4, who's going to win? Top or bottom? The bottom. By how many? 3. And so you can kind of think of it that way too, as opposed to a subtraction. Because if you did a subtraction here, you would get a negative number, which we'll talk about that later. Okay? All right, real quick, we're going to do these couple problems and then the combo problems, and then we'll break. Okay? You with me? Next page now. We're getting close. We're getting real close. Okay, let's look at this one. X to the 3rd, y, over x to the 5th, y. One letter at a time. Flip back over. Flip back over, Miles. Okay? One letter at a time. Let's focus on our x's. Let's focus on our x's. This is a division, so we're thinking tug of war. Who's going to win between x to the 3rd and x to the 5th, top or bottom?
Bottom.
Bottom, by how many?
2.
2. So I'm actually going to make this answer blank my fraction bar. So x is going to win at the bottom by 2. So I'm going to have an x squared on the bottom. So do y'all see what we just did? We're just looking at the x's. Now we're done with the x's. They're finished. Now we're going to look at the y's. What are the exponents of our y's? They don't have anything, so what am I going to write in? 1 here and 1 there. Now they're the same. Who's going to win that tug of war?
Tie.
Tie. Tie simplified to, and that's got to go in the top. So there's my answer. Kind of weird.
So it's 1 over x squared.
At the bottom it says x squared, right?
Yeah, I made this answer blank a fraction bar because it was just going to be too small for me to write. Okay? All right, try the next one. There's 3 different bases. Just go 1 letter at a time. Work your A's, work your B's, work C. Okay? But I always like, if I see a fraction bar from the beginning, I kind of go ahead and draw a fraction bar for myself because I want to know where it's going to go, top or bottom. Okay? You're thinking tug of war here.
There's a C.
You would need a 1 on top.
Okay, who wins with your A's? Top or bottom? Bottom by 2. Notice I'm bringing the base. You have to write the base in. And y'all make sure the exponents look a little bit smaller. So a squared is going to go at the bottom. I'm done with A. Jahan, who's going to win between my B's? By 2. So I put a B to the second power in the top. All right, how many C's were there?
1.
There's only 1, and where is it? At the bottom with an exponent of 3. So if there's only 1, I have to leave it there. I can't just ignore it, but there's nothing that I can really simplify with it. I've got 1A, 1B, 1C. I'm done. Okay? So that's kind of what how this rule works is once you just work 1 letter at a time, you're finished. Now, the next little section, and then we're going to brain break for, I'm going to give y'all 4 or 5 minutes because we've done a lot. Do what?
Anya had a question.
What's your question?
So I noticed at the bottom you said 2, but 7 minus 9 is negative 2.
Okay, so we are going to,
We're looking at tug of war, right?
yes, right now.
So we're just looking to see who's bigger. So where's bigger, the top or the
The
bottom?
bottom.
So then we're going to subtract and get that number, right?
Oh,
So
yeah.
that's why we
it'd
put
be
it on
9
the
minus
bottom.
7 is 2.
Good
There,
question, though.
that is a good question, and it's going to kind of come together. I think next class we're going to talk about negative exponents. Maybe it's today. I don't know. We'll see. No, you're exactly right. If you're following the rule, you are doing that subtraction. Negative exponents, though, are not fully simplified, and so there's kind of a rule that we have to follow with those that we'll go over, and it's going to click as to why it does end up going in the bottom. So you're on the right track. I'm just not ready to get there yet. Okay, so let's go over this. This is a combo. This is a combination of rules, which means we're going to be mixing our products and we're going to be mixing our quotient. Are we ready to do these 2 problems and then take a 5-minute break? Are we ready? Miles? Right in? Yes? We ready? Okay.
2 problems and then a break.
2 problems and then a break. Okay? So, the key with this, 1 letter at a time, take multiple steps. Do not try to do it all in your head. So, when I look at a problem like this one right here, and I'm like, oh, wow, there's a lot. I think let's clean up the top and then let's clean up the bottom. So I'm just going to look at the top right now, okay? If you need to cover that up with your finger like I am, do that. What operation is going on here at the top when I have side-by-side parentheses? Multiplication. So you need to think back to our very first rule. When we are multiplying, I'm going to flip my paper. You don't have to. But when you're multiplying like bases, what are the exponents doing? Adding. So let's just do that step first. Okay, so I'm going to draw my fraction bar out, and I'm going to clean up the top. X to the 3rd times x to the 4th. What's my base? What's my exponent going to be?
7.
How'd you get 7?
Because I added 3 and 4.
3 and 4 is 7. Okay, next base is y. What's this y's exponent? Write it in. What's this y's exponent?
Wait, hold on.
3.
This one has a 1. This one has a 2. 1 plus
I
2
know that,
is.
I know that. I'm just saying. Never mind.
Just thinking out loud?
Yeah.
Okay.
At the end, I'll ask.
So I just cleaned up the top. Now let's clean up the bottom. Is there anything we need to do to clean up the bottom?
No.
So let's just write it over. X to the 5th. I am going to write this as y to the 1. You good? Okay. I am going to write this as y to the 1. So does everyone see what I did here? I'm going to put a little equals. Miles? Yes?
What?
You see what I did? Multiplied on the top, and then I didn't have any multiplication to on the bottom. Now I'm going to tug of war. Now I'm in a division. I'm in a quotient. So here's my fraction bar again.
Or since no one's gonna win on the bottom, do we just put 1?
Or you don't have to put a 1 on the bottom, but you can. Okay? All right, who's going to win between the x's? Top or bottom? By?
2.
So x squared. Who's going to win with the y's?
Top
By?
2.
And then, like Braden was saying, what's left on the bottom, you can put a 1. You don't have to. You could just put x squared, y squared. If it was multiple choice, they would just put x squared, y squared. Okay? So, was that horrible?
No.
It's not horrible. Try the next one. I'm going to draw a little fraction bar. Try this one on your own. Clean up the top, clean up the bottom. Really, really quick one is when you have an exponent of 0. Okay? All right? So, let me make sure I get my vocab right. When a base, everyone with me? Base is the first blank. When a base, whether it's a base that is a number, a base that is a variable, whatever base, if it is raised to a power of 0, if the exponent is 0, then it is equivalent to, what do y'all think?
1.
Let's test it out. Okay? Braden, what is your favorite positive number?
9.
9. Okay? All right, let's go to our calculator. Everyone, we're going to type Braden's favorite number. Type 9. Okay? So y'all know how to get an exponent in your calculator. If you do not, let me show you. There is this little, above the divide sign, I call it a caret, some people call it a house, whatever. If you hit that button, it's going to give you a little upper square where you can put an exponent, okay? So type that, 9 caret, and then we're going to put an exponent of 0. So here's, if you forget this rule or you need a reminder because you're not sure, pick your favorite positive number, raise it to the 0 power, press enter. 1. Nick, what's your favorite positive number?
Like 14.
14 to the 0 power. And we get 1. Heidi, what's your favorite positive number? 12? Okay, I was actually thinking that. That's really weird. 12 to the 0 power. We get 1. So anything raised to the 0 power is equivalent to 1. And Anya, you were correct. Okay. Now, you're not going to be able to test variables in your calculator, but you can always test positive numbers. So, 8 to the 0, real quick. What do we know that's equal to?
1.
Equal to 1. Y to the 0, what is that equal to? 1. Okay. What about this one? A to the 0. 1. B to the 0. What's 1 times 1? 1. Right there. Okay. So a lot of times if I see something with a 0 power, I honestly just mark it out because it's a 1. It's like a 1 times 1. All right, what about this one? K squared, m to the 0, n. Is that going to be 1 as my final answer? No. What's the only thing that 0 is attached to in this problem? What's m? So I only can get a 1 from this guy. Okay? So what is my answer? K squared times 1 times n. That's my answer.
4.
4? How do we get 4? 2 people said 4. How'd y'all get that? Okay? If on a problem like this, k squared times 1 is still k squared times n is still n. That's all I can do. Okay? So it's almost like, again, if you see a base attached to a 0, just mark it out and put a 1. If there is other stuff left over that is not attached to 0, like these two, those two still have to be there. So don't just see a 0 and assume the whole thing is 1. You got to be kind of careful about what actually is 1. So I want you to try, it's another combo. Okay, so expect to get some zeros in there. Another combo problem here, and then we're going to move to our very last roll. Okay, think y'all can try these two? Go for it. We can help. Nick, what did you get on the first one?
Okay, so make sure you understand that.
What do you mean?
What'd you get for your final answer over here?
B was on the bottom.
B to the
Bottom.
5th is on the bottom. What was on the top?
And then A was canceled out.
Mm-hmm.
And then C4 on the top.
C to the 4. Okay, so again, this was a 2-step problem. So you ended up having to do the product rule at the top, which means you were adding. Give that guy a 1. This was B to the 3. This was c to the 5. The bottom, you didn't have to do any, like, work on that first step, so it's just a rewrite. I would give it a 1. But why did you say the a's canceled out? You are correct, but can you tell me why?
They were above 7.
They were both 7. Now let's kind of take this back to the quotient rule. The quotient rule, really, we're subtracting. What is 7 minus 7? 0. What is anything to the 0 power? 1. So that also confirms why those are canceling out. You can think of it as a tie. You can think of it as I will get a to the 0 power, which is just a 1. Miles, you wrote in a 1. Is that okay if you write in a 1 at the top?
Sure.
Do you have to?
No.
No, but it's okay if you do. And so this is your answer here. So I think the next problem was pretty similar. Mohammed, what'd you get for the next answer? Final answer.
I got x to the power of 2.
X to the power of 3. Anything on the bottom?
I just put 1.
Over 1. You don't have to put over 1. This works as your answer there as well. And I think something canceled out. The y's must have canceled out as well. Okay? And then these were just one rule at a time, so we'll skip those. Okay, last thing. Last thing we're going to talk about. I know I told y'all we had a lot. Wasn't lying. These are the big rules, though. Next class is just going to be more practice on this, and we have to talk a little bit about coefficients. But
Quick question. So where's on the other page we skipped this little box, right? This little box.
yeah, we did. Yeah. I'll put it on my answer key on Canvas, but I'm just trying to kind of simplify because we got a lot. Okay? All right. Power of powers. So this is our final rule. Power of powers. I call this the outside power. Outside power rule.
Oh, we're done after this.
I know. We're not. We're done after this. Power of powers. Okay. So when a base with an exponent is raised to another exponent, so it's written like if you had x to the 2 to the 3. Power to a power. An outside power like that. So exponent to an exponent. Oh, there's your example. Right there. You will, this rule is different, okay? This rule we are going to multiply. Multiply the exponents, okay? Sometimes people say this is kind of like the distributing rule, and it sort of is, okay? You kind of draw it like that. Remember, an expression is fully simplified when the variable shows up only, how many times? We've done this 3 times. How many times does it show up when you're done?
1.
Once. Very good. Okay? So here's what the rule looks like. Again, this is on your chart. So it shows an exponent to an exponent. You multiply those in. Okay? We're not going to expand this because this is going to take forever. We're actually just going to go right here and do some practice here. So let's look at this one. X to the 4th to the 3rd power. So do y'all see how this is different from the product rule? This is no longer side by side. How many x's are there in this problem? How many x's are there right here? Well, no. How many bases are there?
1.
Just one. And that base is x. Okay? But there's 2 exponents. There's an exponent to an exponent. So my rule says I'm going to multiply the outside power to the inside power. And what is 4 times 3?
12.
So x to the 12th ends up being my answer. I wanted to show you that this is different than a problem. Don't write this. Just look at me. This is different than this. Okay? These two. Compare and contrast. How are they different? Anya.
One is a multiplication, one is just x to the power of 12.
So this is a actual multiplication of 2 separate bases. This is a base with a power to another power. So this we would add, this we would multiply. So I want you to kind of see how they look different, okay? You really got to pay attention to like the outside power thing there. So x to the 12th, and then I'm done, okay? This one, m to the 3rd, n to the, what's n's exponent?
1.
1. Give that a 1. And then we have an outside power of 2. Well, what am I going to do with that outside power?
Multiply it.
Bring it in. Bring it in. Bring it into all the exponents. Okay? So how many exponents did I bring it into, Zane? 2. All right, let's talk about m first. M to the, multiply for me, Zane. 3 times 2 is?
That's gonna be 6.
Okay. N to the 1 times 2 is? Times 2 is? 2. And then we're done. Okay? Over here, we got another x outside power. What's our outside power this time? Are all of these attached to a 0? So bring it in. 0, 0, 0. So what does that become? What's 0 times anything?
0. 1.
Well, 0 times anything is 0. 0 as an exponent is 1. Okay? So this becomes m to the 0, n to the 0, p to the 0. 1 times 1 times 1 is 1. Okay? If the outside power is 0, that whole thing's going to be 1 every single time. What about this last one? What's the outside power? 1/2. Does that scare us? No. What do we do with outside powers? Multiply them in. Okay? So let's do the x first. X to the 6 times 1/2 is what? 3. 3. And then y, 2 times 1/2 is 1. Do we have to write the 1? No. Can you? Yes, you can. There you go. Okay? All right, let's try to finish these 4 problems and then we'll be done for the day. We'll just save the homework stuff till later. Okay? These are some combo rules here. So I want you to kind of think about, you have to follow PEMDAS. What is PEMDAS?
Order of operations.
Order of operations. P-E-M-D-A-S, which means outside exponents are going to be N. So, E. So they need to be happening first. If you have an outside power, you need to bring that in first. So on this problem right here, do you see an outside power right here? What am I going to do with that? Multiply it in. Do you see an outside power over here? Multiply it in. It's only attached to that one parenthesis. So you need to be doing outside powers first every single time. Okay? Emma, you want to help me with this one? What is this one going to become? X to the 10th, 5 times 2. Y to the 3 times 2 is? Okay, on the other side, this one I'm bringing in a power of 3. You can keep this in parentheses. Cruz, help me with this one. This is going to become x to the 15th. Y to the 6th. Now, are we done? Are we finished with this problem?
No.
How many x's do I have?
2.
How many y's do I have?
2.
I'm done when they show up only one time. So now I'm going back to, what rule is this? What am I going to do with those exponents? I add the exponents now. Okay? X to the 10 plus 15 is 25. Y to the 6 plus 6 is? And we're done there. Okay? So these are some combo rules. I want you guys to try to finish these. We'll help you. We'll check. We still got like 12 minutes. And then when we're done with these, then we'll be finished. Okay? I know. It was a lot.